All right, today we're going to talk about the initial rates method. Just as a reminder from yesterday, the rate law shows how fast reactants are being used up when products are being formed. The rate law can only be experimentally determined. Okay, it is the rate law is equal to the rate times the constant K times the concentration of a reactant to some power. Okay, so the initial rates method is used to calculate the experimental rate law. Data is typically organized into a table. We'll This is just simple algebra. We'll follow these 5 steps. We'll set up the two rate laws using any two experiments from the data table. We'll divide the two rate laws. You're going to cancel out unnecessary items. This is a necessity. Okay, you're going to cancel things out that appear the same. That way, you can solve for one of the concentrations and then find the exponent of one of those powers. And then you'll simplify and solve for exponent. And you'll repeat this as many times as necessary. And then you could also be um, asked to find the value of K. So I know that's a lot, so let's work out an example of this. This is how your problem is going to be set up. Use the table below to determine the rate law uh, for the reaction. So we know that our generic rate. Okay, so we want to determine the rate law for the reaction of CO plus Cl2 yields CoCl2. So we know that the generic rate law rate will be equal to K, and then CO to some power, I'm going to call that X, and then Cl2 to some power, I'm going to call that Y. Okay, it doesn't matter. You can use X, Y, A, B, anything you want to do. So to determine the rate law, it says to divide out any two things. So I'm going to divide any two of these experiments. Now, I want to choose intelligently, okay? I do not want to divide experiment one, experiment two, because that'll just give me one. And I know that there's one to the first power is one to the second power is one to the third power is one to the zero power is one. So I want to pick out any two experiments, but I want to make sure that my rates, when I divide, don't equal one. So I'm going to divide. I can do 3 and 1 or 3 and 2. Doesn't really matter. Okay, I'm going to use 3 and 1 here right now. So I'm going to do, to find this, I'm going to do experiment 3 divided by experiment 1. So I'm going to substitute my rate. My rate was 7.8 times 10 to the negative 25th equals K. That's my rate constant. And this is experiment 3. So I'm going to use 0.200 my CO concentration, and that's to the X power, and then 0.200 to the Y power. And I'm going to divide this by experiment number 1. So my rate in experiment 1 is 3.9 times 10 to the negative 25th equals K. And then my concentration of CO is 0.100 to the X power. My concentration of Cl2 is 0.200 to the Y power. So I need to cancel things out. So I know that K cancels out. I know that 0.2 to the Y power divided by 0.2 to the Y power is 1. So that cancels out. Now I'm going to simplify this down, and I'm left with 2 equals 2. 2 equals 2 to the X power. So now what power, 2 to what power equals 2? And we know that 2 to the first power equals 1. So X is 1. So I'm going to come up here. I'm going to erase this X right here. And I'm going to put 1. Now, I still haven't figured out my rate law. I still need to know what Y is. So I'm going to pick any two experiments again. And this time I'll probably use experiment 3 and experiment 2. So I will have 7.8. Now I don't, 7.8 times 10 to the negative 25th. So this is 3 over 2. And this first one was 3 over 1. Equals K 0.2. Now, It's now no longer 0.2 to the x power. It's now 0.2 to the first power times 0.2 to the y power. And I'm going to divide this by experiment 2, which would be 3.9 times 10 to the negative 25th equals k 0.2 to the first power, and then 0.1 to the y power. This simplifies down into the k's go away, this goes away, 7.8 times 10 to the 25th divided by that. I'm going to work over here around room. So now I have 2 equals 2 to the y power. So we know in the same way that y has to equal 1. So my rate law, my rate law is now rate equals K, carbon monoxide to the first power, and then Cl2 to the second power. So this is first order with respect to CO, and it is first order with respect to Cl2, and it's second order overall. So example 2. Example 2 says use the data from the table. Once again, this table information will always be given, okay, to determine the rate law and the value of K for the reaction 3A squared, or 3A plus B yields A3B. And I also want to determine K. So I have 2 things I need to do this. I need to determine the rate law, and I need to determine K. So to do this, I'm going to pick out any 2 experiments. Like I said, it doesn't matter which one I pick out right now, because I always want to have the bigger rate over the smaller rate. I should have said that in the last example, the bigger rate. So I know my rate law, my generic rate law rate is going to equal K to A to some power, so A to the X power, and then B to some other power. We'll call that the Y power here. So to determine the rate law, I'm going to pick out any 2 experiments. I want to make sure things cancel, okay? I want to make sure something has to cancel. So I can't pick out experiment 2 and experiment 1 because that will just give me a 1, and 1 to the 0 power, 1 to the second power, 1 to the third power, all equal the same thing. So to do this, I'm going to pick out experiment 3, and I'm going to do experiment 3 divided by experiment 2. So I'm going to do 3 divided by 2. So the rate of experiment 3 is 1 equals, or 0.1 equals K, and then 2 to the X power, and then 4 to the Y power. And I'm going to divide this by the second experiment. So 0.025 equals K, 1 to the Y power, or probably 1 to the X power, wrote Y, 1 to the X power, and then 4 to the Y power. K's cancel, 4 to the Y's cancel. So now I can simplify this down. 0.1 divided by 0.025 is 4. So 4 equals 2 divided by 1 is 2. So 2 to the Y power. So what number, 2 to what number, or 2 to what power equals 4? So we know that Y equals 2. So I made a mistake there. I apologize. This should have said X and not Y. That's my mistake. I couldn't read my messy handwriting. So 2 to the X power, 2 to the X power, so X equals 2. I'm going to come up here and I'm going to erase my X, and I'm going to replace it with a 2. Now I still need to find the value of Y. So the value of Y, I'm going to pick any 2 experiments. Once again, I don't want things that, I don't want ones, okay? Because ones, are kind of a hard thing to do. So in this one, I'm going to do experiment 3 divided by experiment 1. So 3 divided by 1. And once again, I always want my bigger rate on top. So I'm going to have 0.1 equals K, then 2 to the second power times 4 to the Y power over 0.050 equals K, 1 to the second power, and then 2 to the Y power. So I don't have as much stuff that cancels out this time. The only thing that cancels this is 1K. These do not cancel, so I need to simplify this out. So now I'm left with 1 divided by 0.05 is 2. So 2 equals 4 over 1, and then 2 to the y power. So 2 equals 4 times 2 to the y power. I'm going to divide each side by 4. And I'm left with 0.5 equals 2 to the y power. So now I need to know what value has to, what the value of y has to be. It's not 0 because 2 to the 0 power is 1. It's not 1 because 2 to the first power is 2. It's not 2 because 2 to the first power is 4. So I'm probably going to pick out a negative exponent. And I know if 2, put in the calculator, 2 to the negative 1 power is 0.5. So y is equal to negative 1. That's just elimination. You're going to try probably 1, 2, 1, 2, 0, negative 1, negative 2, and go into there. So up here, I'm going to come to replace y with negative 1. So now I am second order with respect to A, the negative first order with respect to B. My overall rate would be first order because 2 minus 1 is 1. I'm not finished with this question yet, though. This question asked me to also find the rate law and the rate constant. So to find the rate constant, it doesn't matter which experiment I pick. I'm going to pick experiment 3 because that's what I've been dealing with. And I know everything in this except for K. So I know I'm at 0.1 equals K. Then I'm at 2 to the second power. And then 4 to the negative first power. And it is just simple algebra from here. So 0.1 equals K. 2 squared is 4. So K times 4. 4 to the negative first is 0.25, so times 0.25. And this simplifies down into 0.1 equals K. And that's how you determine the initial rate method. We'll do this again tomorrow with a little bit more difficult rates.